Hello, calculus fans. Let's take this picture. It shows a function y equals f of x. And what we would like to do is find all the values of x at which this function is discontinuous. So you may want to write down this function. We'll be referring to it a few times. Draw yourself a graph. So let's go ahead and review the definition of continuity. Remember that a function is continuous at x equals a if three things have to happen. The function has to be defined, that is, a has to be in the domain of the function. The limit of the function has to exist. But not only that, but the limit of the function has to equal the value of the function at that point. And if you go look at the picture, there's really only 3 points where we have to consider the possibility that the function is discontinuous. X equals -1, 2, and 3. In between those values, it's a nice smooth curve, so it is definitely continuous everywhere else. Now we're going to consider each one of those points separately. Now our function is definitely continuous everywhere else, because for the rest of the graph you can always draw those portions without picking up our pencil from the paper. Now there's one point at which the first condition is not met. That is, the one that says that the function has to be defined. That's when x is equal to 3. If you go look at the graph, there's a hole there, and we haven't even redefined it anywhere else. That tells us that the function is discontinuous at x equals 3. Okay, now let's look at what happens at x equals -1. We can see that if we take a left-hand limit, we get 0, but a right-hand limit is 1. Now our one-sided limits are equal, but they do not agree. So the limit as x approaches -1 of f of x does not exist. So the second condition is not met. That means that f of x is discontinuous at x equals -1. And finally, let's take a look and see what happens at x equals 2. Now there our function is defined. It's f of 2 is equal to -4. So condition 1 is met. And we can even see the limit as x approaches 2 from the left is 0 and from the right is 0. So the one-sided limits exist and are equal. That tells us that the two-sided limit is equal to 0. But remember that f of 2 is equal to -4, so the third condition is not met. The value of the function is not equal to the limit of the function, and so that means that f of x is discontinuous also at x equals 2. So our conclusion is that the function is discontinuous at x equals -1, 2, and 3. And those are the only points of discontinuity. Okay, that's all for now.